All right, these are our pre-calc notes for section 2.5. We're looking at complex zeros and the fundamental theorem of algebra. We are going to spread this out over 3 days. For today, we'll just be focusing on our first objective here, using the fundamental theorem of algebra and the linear factorization theorem. Then we'll come back next day and do complex conjugate zeros, and then the third day factoring with real number coefficients. This section is important because the topics provide a complete story about zeros and factors of polynomials with real coefficient numbers. So we're looking at all options here, both imaginary, rational, irrational, everything. All right, so our first two theorems. It says these theorems are existence theorems. They tell us of the existence of zeros and linear factors, but do not show us how to find them. The first one is called the fundamental theorem of algebra. It says a polynomial function of degree n has n complex zeros if we count real and non-real. And some of those zeros may be repeated. And then the second theorem is the linear factorization theorem. It says if f of x is a polynomial function of degree higher than 0, then f of x has precisely n linear factors, and each of those factors can be written down. We may have a leading coefficient here. That might just be a 1, but we may end up with a number there. And then the z1, z2, etc. are all of your complex zeros. They are not necessarily distinct numbers. In other words, some may be repeated. So if you have the same factor repeated more times, it has that multiplicity piece, and it counts as individual zeros. Basically, if you have a polynomial of degree n, you will have exactly n factors and n zeros, counting both real and imaginary. All right, the fundamental polynomial connections when we talk about complex numbers. It says the following statements about a polynomial function f are equivalent if k is a complex number. X equals k is a solution or root to f of x being 0. K is a 0 of the function, and x minus k is a factor of your function. The only thing that we can't say is they're not X-intercepts. When we have complex numbers here, we can have some that do not show up as X-intercepts on our graph. All right, so our first example, we are creating polynomials from the factors. In other words, we're FOILing this all out, multiplying it all out to get the original polynomial. It says write the polynomial function in standard form and identify the zeros and any X-intercepts of the graph. All right, so we start out f of x being x minus 2i times x plus 2i. If we FOIL that, we've got x squared. We have positive 2ix. We have negative 2ix. So those will cancel. And then we have a negative times a positive, so negative 2i times 2i is 4i squared. But if you remember from previous chapter, I squared is equivalent to negative 1. So this is going to simplify down to be x squared. If that's negative 1, we end up with a positive 4. All right, now they asked us to find zeros and X-intercepts. Our zeros, if we go back looking at our original factors, we have the first factor giving us a 0 at 2i. The second factor gives us a 0 at negative 2i. And because those zeros are imaginary, we would say we have no X-intercepts. They will not show up as parts of your graph. All right, our second example. Our first factor is x minus 5. Our second factor is x minus root 2i and x plus root 2i. Notice that the I is not under the square root symbol. So some books will write that as I root 2, or in our past chapters we've written it as I root 2 just to make that clear. So be careful when you're FOILing that out. Because these are conjugates, I would FOIL those out first. and save the x minus 5 till later. All right, you've got x squared minus root 2i times, x minus root 2i times x plus root 2i. The insides and outsides will drop out. So x times x would be x squared. And our last term, we have a negative times a positive, so negative. We have root 2 times root 2, which is 2. And then we have I times I, which is I squared. And again, we can simplify that I squared to be a negative 1, which makes this a positive 2. I'm just going to rewrite that since it didn't come out very good. All right, so we've got x minus 5 times x squared plus 2. And now we need to FOIL that out. So x times x squared would be x cubed. Insides will give us negative 5x squared. Outsides give us a positive 2x. And last gives us a negative 10. And I did it in that order to get it in standard form like they asked. All right, so our zeros. Going back to our original expression, our zeros are 5, positive root 2i, and negative root 2i. And then x-intercepts. The only one that's going to show up as an x-intercept would be the real one. So our x-intercept would be 5. All right, question 3. F of x equals x minus 3 times x minus 3 times x minus I times x plus I. Again, these are conjugates, so I would FOIL those out first. We can FOIL this one as well. All right, so taking those two, x minus 3 times x minus 3 would give us x squared minus 6x plus 9. And when we FOIL x minus I times x plus I, we have x squared, insides and outsides cancel, and minus I squared. But I squared is negative 1, so this becomes x squared plus 1. And then we need to multiply all of this together. All right, so we have x squared times x squared. So x cubed, x squared times 1. Then we have negative 6x times x squared. Sorry, let me try that again here. All right, x squared times x squared is x to the 4th. X squared times x is 1x squared. Taking negative 6x times x squared would be negative 6x cubed. Negative 6x times 1. And then a positive 9 times x squared. And a positive 9 times 1. And then putting that in standard form and combining all our like terms, we have an x to the 4th. We have a negative 6x cubed. We have a positive 10x squared. And we have a negative 6x and a positive 9. All right, so our zeros. Again, from our original expression, we have 3 as a 0, and it has multiplicity 2. In other words, it counts as 2 of my zeros. It's repeated. And then I also have positive and negative I. So I do have all 4 zeros. My x-intercepts, though, are only going to be the real ones, so the 3. And because of the multiplicity of 2, it is going to be tangent at that value. In other words, it's going to touch but not cross the x-axis. All right, so go ahead and pause the video. I want you to try the next one on your own, and then turn it back on and check your work. All right, checking. We have x plus 3i times x minus 3a. Those are conjugates. So we can FOIL those together and get x squared minus 9i squared. Then we have 3x minus 2's that all have to be multiplied together. I'm going to hold off on one of them and multiply the other two together. We've got x squared minus 4x plus 4. Cleaning up a little bit, the I squared is negative 1, which makes this x squared plus 9. All right, and then you have a choice. You could multiply x squared plus 9 and x minus 2 first. We could FOIL that out and then multiply it to our trinomial at the end. Or you could multiply your x minus 2 times your trinomial and then multiply in your x squared plus 9. Either way will work. I'm going to do these two. So we have x to the third. We have minus 2x squared plus 9x minus 18. All right, multiplying all of that out. We have to take x cubed times the whole trinomial. We get x to the fifth. We've got negative 4x to the fourth, and we have 4x cubed. Distributing the negative 2x squared gives us negative 2x to the fourth. We have positive 8x cubed, and we have negative 8x squared. Multiplying the 9x gives us 9x cubed minus 36x squared plus 36x. And then our last term, distributing the negative 18, we've got negative 18x squared positive 72x minus 72. And then combining all of those terms, our polynomial f of x equals x to the fifth minus 6x to the fourth plus 21x cubed minus 62x squared plus 108x minus 72. All right, and then our zeros. From the original factorization, we have 2. It has multiplicity 3, so it accounts for 3 of our zeros. And then we also have positive and negative 3i. So there's all 5 zeros. Again, the only ones that are going to show up as X-intercepts would be the 2. And because it has multiplicity 3, it's going to cross the x-axis with a twist. All right, our third theorem. We're looking at complex conjugate zeros. It says, suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers with b not equaling 0, and a plus bi is a 0 of the function, then its complex conjugate a minus bi is also a 0. In other words, all non-real zeros occur in conjugate pairs. And most of the time they will give you one of them and assume that you know that the other one is also included. All right, so our example, it says find a polynomial function with integer coefficients with minimal degree, which means we don't want to consider any repeated zeros. We want them in the smallest amount possible. And it says that negative 5, 3, and 6i are zeros. So if 6i is a 0, then negative 6i is implied as another 0. So we have to include that one. All right, so our function, we'll start out with our factors. If negative 5 is a 0, then the factor x plus 5 is one of our factors. If 3 is a 0, it came from the factor x minus 3. And then if 6i is a 0, it came from x minus 6i. And remember the implied one, the negative 6i, would give us a factor of x plus 6i. Again, those non-real ones will always occur in conjugate pairs. So if I were foiling this one out, I would FOIL the first two, and I would FOIL the third and fourth ones, since those are conjugates. So foiling my first two pairs here, we've got x squared plus 2x minus 15. And foiling my conjugates, we've got x squared. Insides, outsides drop out. We get negative 36i squared, which is actually positive 36. All right, and then we want to multiply that all out. We are looking for the polynomial. So x squared times x squared would be x to the fourth. X squared times 36 is 36x squared. 2x times x squared is 2x cubed. 2x times 36 is 72x. And negative 15 times x squared. And then negative 15 times 36. So negative 540. All right, combining like terms, my polynomial is x to the fourth. Combining my, let's see, we've got 2x cubes. And then combining my x squareds, 36 minus 15 would be 21. X squareds and 72 x's and minus 540. All right, now remember, you can always type that in your calculator, and you could check to see if the negative 5 and 3 show up as zeros. Obviously, you won't see the 6i and negative 6i, since they are imaginary. All right, example 2 says write a polynomial function of minimal degree in standard form with real coefficients whose zeros are negative 3, 4, and 2 minus I. So again, the implied zero is 2 plus I. All right, so if negative 3 is a 0, x plus 3 would be your factor. If 4 is a 0, then x minus 4 is your factor. And be careful here. We have 2 minus I as the 0, so it's x minus 2 minus I. Clean that up a little. All right. And then we said that 2 plus I is also a 0, so we have x minus 2 plus I. Okay, so the first two we can FOIL out pretty easily. We've got x squared, 3x and negative 4x would be negative 1x, and a negative 12. The tricky part comes with this next piece. They are conjugates. It's just hard to see it right now. So what I want you to do is distribute the negative. So this becomes x minus 2 plus I. And the second one becomes x minus 2 minus I. All right, and then what we're going to do is we're going to treat this as if there were parentheses around those. We're going to group those together. And now you should be able to see the conjugates. You have this plus I, you have the same thing minus I. So when you FOIL that out, the insides and outsides should drop out. All right, so FOILing this, we are going to take x minus 2 times x minus 2, which gives us x squared minus 4x plus 4. Then we take insides and outsides and they drop out. And then we have our last term, I times negative I, so negative I squared. Cleaning that piece up gives us x squared minus 4x. The I squared here is a negative 1 times the negative makes it a positive 1 plus the 4 makes this a 5. All right, and now we have to multiply those all together. So again, distributing our x squared first, we've got x to the fourth x squared times negative 4x is negative 4x cubed. X squared times 5. Okay, distributing the negative x, we have negative x times x squared, or negative x cubed. Negative x times negative 4 is positive 4x squared. And negative x times 5 is negative 5x. Our third piece, negative 12 times x squared. Negative 12 times negative 4x would be 48x. And negative 12 times 5 is negative 60. All right, combining all of our like terms, our polynomial becomes x to the fourth minus 5x cubed minus 3x squared plus 43x minus 60. All right, we have one more that we're going to try today. It says write a polynomial function of minimum degree in standard form with real coefficients whose zeros are 1, 1 plus 2i, 1 minus I. Now, we do need to be kind of careful here because there's two different imaginary ones, and we need to also include their conjugates. So if 1 plus 2i is a 0, then 1 minus 2i is also a 0. If 1 minus I is a 0, then 1 plus I is another 0. All right, so this one's going to take a little time. Pause the video for a minute and just write out all 5 factors. All right. So our function f of x equals x minus 1, x minus 1 plus 2i, x minus 1 minus 2i, x minus 1 minus I, and x minus 1 plus I. All right, again, I would multiply conjugates together first, so let's hold off on this x minus 1 for a minute. And let's deal with the second and third pair, and then the fourth and fifth pairs together. Okay, so again, distributing, we have x minus 1 minus 2i, x minus 1 plus 2i, x minus 1 plus I, and x minus 1 minus I. All right, and we're going to regroup so that we can see our conjugates. All right, so multiplying the second and third factors. X minus 1 times x minus 1 gives us x squared minus 2x plus 1. And then a minus 2i times a positive 2i is negative 4i squared, which is positive 4. Our second set, we're taking x minus 1 times x minus 1 again. So x squared minus 2x plus 1. And then we have an I times a negative I, so negative I squared, which is a 1. Combining like terms, we've got x squared minus 2x plus 5. And we have x squared minus 2x plus 2. All right, let's multiply our two trinomials together. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times 2 is 2x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is positive 4x squared. Negative 2x times 2 is negative 4x. And then the 5 gives us 5x squared minus 10x plus 10. All right, combining like terms, we have x to the 4th minus 4x cubed plus 11x squared minus 14x plus 10. And now we finally can distribute that x minus 1 in. Distributing the x gives us x to the 5th minus 4x to the 4th plus 11x cubed minus 14x squared plus 10x. Distributing a negative 1 gives us negative x to the 4th plus 4x cubed minus 11x squared plus 14x minus 10. And combining it all, we've got x to the 5th minus 5x to the 4th plus 15x cubed minus 25x squared plus 24x minus 10. So once again, you could type that in your calculator to check your zeros. However, there was only one real zero at x equaling 1. So that's the only one that you would see on your calculator as an x-intercept. All right, we're going to stop here for day 1 and pick that up tomorrow. And I will get your assignment in just 1 sec. Okay, so for day 1, you are going to do page 215, 1 through 15 odd, 17 through 20, 21 to 25 odd. That is actually day 1 and part of tomorrow's, so see how far you can get. I would try for sure get these first ones done here. If you can go a little further based on what we've already taught, go ahead and continue working.